if I want runtime, we forgot the first bullet point.
Yeah, my fault.
Ben wasn't here to yell at us.
I forgot. I lost my train of thought, but basically, yeah, the different process types and being able to do that in the future, that might be something to think about, and why we wouldn't want to put them on the image config.
That's a good point. When you're specifying environment variables, sorry, in pack though, like if it's going to be in the, in Project Toml, or if you're going to pass -- runtime env, would you expect then to have some syntax for saying that you're just setting those environment variables for a particular process? If given that the user is not contributing the process types, right, the Buildpacks are contributing the process types, is there a need or a way to be specific about where those environment variables apply? Isn't it kind of like the Buildpack's responsibility to say what environment variables apply to the process types that it's contributing? We've never talked about mapping. Sorry, go ahead.
I'm sorry. Yeah, I think when we talked about it before, it was like, yeah, Pack probably wouldn't have that, I think, at first, but like the Project Toml might be a place where you would want to be able to make sure that you're specifying, like from a user's perspective, envs that only belong to the web process. And it seems like something that you'd want to not box yourself out of potentially.
Torn, because I feel like it's convenient to set these things on the image, right? It's straightforward. It fits people's expectations. But I also wonder, because we aren't doing that with Buildpack provided environment variables, like maybe it gets confusing. People start seeing environment variables directly in the config and they expect all of them to be there.
Yeah, I guess that's why I was thinking about, it seems like it's like a Buildpack that basically runs last or whatever, so it can override, or because it is like what the user is setting.
I feel like in the back of my head, I have a goal of making it possible to use cloud-native Buildpacks without the launcher at some point in the future, where the environment variables in the directories could all be evaluated at the end of the build process and then applied, and you lose some functionality, right? You wouldn't be able to input runtime environment variables that then get processed automatically by Buildpack code and then sent to the environment. But that mode seems like it would be useful for some use cases, especially because our launcher is in Go, and so for functions, there's a little bit of overhead with the, GC starting up and everything. And so this feels like another place where we would take a strong dependency on the launcher.
Maybe this isn't the place to start, though. Like start trying to break down that dependency. Like you'd sort of want to figure out what you're doing for everything. And then because this looks just like a Buildpack in some ways, whatever the solution for the Buildpack is could be applied to this when we figure that out.
Yeah, another idea, like you said, Paketo has basically some Buildpack that more or less does this. It makes me think even inside of Project Toml, if there is just like a community sanctioned Buildpack that does this functionality, and there just needs to be more configurability for doing Buildpacks. Like being able to pass in a bunch of stuff to a Buildpack that could then do this. Makes me think of the discussion we had, I feel like it was 2 weeks ago or something, similar with like inline Buildpacks and like wanting to expose more functionality inside Project Toml for simple things.
I guess I don't know why we wouldn't just have the lifecycle do it, because I feel like it's more straightforward for users in some ways.
It's about shifting the extensibility from something that is managed and maintained by the project to something that could be independently maintained, right? I mean, I could see that as being the argument. If we consider like Buildpacks as the extension point, right? Like use the set of Buildpacks that, let's say, even the project maintains. I know we haven't discussed that in the past, but you have these Buildpacks that then just provide additional functionality as you wanted to, instead of adding the complexity to the core system of the lifecycle, and then adding that contract to anybody else that wants to adhere to that contract, right?
I think I like about adding things that are core concepts directly to the lifecycle is simplicity in that like your platform API version is going to tell you what's available. You don't have to worry about coordinating versions of different components. And I think the sort of the syntax for how we do this with the Paketo build pack, like one of the reasons I want to bake this into the lifecycle, like all the users that I support right now have this functionality right through this build pack, but I think the interface is less than ideal because you need to pass normal build time environment variables, but we have special prefixes like BPE underscore append before your key name. It's just like a little bit ugly when it'd be nice if people could just directly set the things they're interested in.
I have maybe a different approach for getting to the same conclusion, because I think we're talking about philosophical reasons for the how we might include it or exclude it in different parts of the interface, but it may be that there are requirements for how this behaves that mean that we're kind of driven to use a file-based solution. So like, for instance, do we expect runtime environment variables to be set before the Buildpacks supplied runtime environment variables or afterwards? Like, should their input be processable by the lifecycle or not? If the lifecycle sets them in the environment at the very end, and then the Buildpack environment variables run afterwards, they'll get overridden. Like, what are our expectations about the behavior of user supplied runtime environment variables through pack build -- run -env? How would we expect those to interact with the other build packs? Because that may make our decision easier on the for what's right for the interface. Or for
I like the idea of them always going last. So
like
that
override,
prepend puts it at the very beginning and append puts it at the very end. And you don't have to think about the order as much from the user's perspective, and then sort of override works very naturally.
So it's override. So what we're talking about is really an override of the build pack provided environment variables that get loaded dynamically during launch. And in that case, baking it into the image would be, it'd be doable. Like, you could read it and then you could write it afterwards or something in the launcher, but that would be pretty weird. So that would push me away from baking it directly in.
I think there's two questions here. Like, I think you sort of return to baking into the image config, but I feel like there's a question about whether, even if it's a file-based solution, like, does the lifecycle create these files, or just like you have a build pack? But I think having a build pack sort of introduces concepts around order and other things that I'm not sure we want to get into when they're like very straightforward things. I don't think it's just environment variables. I think labels, process types, and like maybe even app slices are things users should feel to set.
I think we can do both, right? Is essentially, I don't think you're arguing for not doing it in a build pack, just having core functionality that would.
I already wrote a build pack that does this, so I'm not saying that that's a bad solution, just that we have it, and I think the lifecycle would be better.
Yeah, I think more my point was I don't think the configuration in Project Toml or whatever is sufficient enough to make that a good experience for build packs, which is maybe just a separate tangent.
What do you mean by that?
Like, I think it would be nice when you're like saying I want to use this build pack in Project Toml to be able to potentially pass the config of like the runtime and bars you want to use as part of that in the Toml file. I guess, how are you doing it right now in the Paketo runtime and bar build pack?
Well, right now you set a build time environment variable with a special prefix, and the build pack strips off the prefix and sets it as a runtime environment variable. In the simplest case. So you either set it in your M section of Project Toml or pass it on a command line with an M flag if you're using pack.
Do you allow for the separate operations?
We do. So there's like different prefixes that designate different operations, and then it will strip off the prefix and write the file and add a type at the end.
I guess I was maybe suggesting something like extending the build.buildpacks thing in Project Toml. So potentially you could pass in specific stuff for that build pack. Because I think if you think about the interface as like it is linked to the build envar, it gets really gross because I think it runs into the issues, potentially some stuff Steven's talking about, where it's like you really do potentially want them to be separate. Like I don't think you necessarily always want runtime stuff linked to stuff you're passing to build.
That's sort of why I think instead of it being a configuration for a build pack, it should be a totally separate launch configuration. Here are my launch environment variables. Here's my labels.
Yeah, I'm sort of envisioning it as another file input that exporter would read, right? Like, because none of the build pack phases need it except for exporter that we're talking about because it's a last in sort of thing. And yeah, we might have prepare that reads a project Toml and spits out this file intermediate file that sort of represents these envars or something. Yeah, I don't like mounting it in project or in platform. I don't like writing it there just because of the override reasons. Like I don't want volumes like wiping it out on accident or something.
What sort of things would end up in an environment variable that would only be applicable at runtime that a build pack wouldn't want to tweak or look at or that kind of stuff? Because we're not talking security or credentials or anything like that. That's going to have to be dynamically injected. So you're talking some sort of static config that's going through to the application. Because if you're talking a configuration that's going to a build pack to say whether you're building native or whether you're building JVM based for Spring Quarkus, whatever, then that could be an environment variable that's obviously being read by a build pack. But then you start thinking about if you're trying to set properties on the application that were a function of what a build pack did, then the build pack's the best placed thing to understand how to manage that, because over time that's going to shift. And then your build pack can take the old values that came in and it can mutate them before it sets them into the output. So it's an important functional point in the chain then of managing that data.
Maybe an example could be, say you have a really simple Java build pack that doesn't do a lot of fancy JVM tuning or whatever, right? Just kind of installs Java and then that you're providing a jar as your source directory, and then as a user you want to add some JVM tuning properties into the image so you don't have to put them in your K8s deployment configuration when you run it, right? It might be annoying to have to find a build pack that's going to understand, oh, I need to take some, or create a build pack that will say, oh, I need to take some JVM tuning parameters that are going to be supplied as build time environment variables and make sure I export them out to runtime environment variables. But I agree that I think that we have gotten this far as a project without the ability to set runtime environment variables in the image is indicative that it's maybe not as common a use case that we imagine it is. I haven't seen a lot of people using the build pack
all the time on the Paketo side. So there are a couple cases where existing Paketo build packs, not the Java ones, will take the build time environment variable and set it at launch time as well. But I feel like this is less explicit, but the build pack's trying to do something convenient, but sometimes users want a different value at build and launch time, so you don't really have that option available to you. There's definitely been cases on the Spring side as well where someone wants to append argument to their Java command, at launch time, I want you to respect this additional profile. And they don't want to have to specify that every time they're deploying it, but it's not something they want.
It's just in a lot of the stuff that I've seen, those particular ones, and the JVM tuning one as well, would be something you would supply via the environment dynamically at deployment time, rather than something that you would be baking into an image and hard setting forever, because that prevents that one image then ever being tuned differently, to do your red-black testing and stuff.
Well, you could always tune it differently at launch just by overriding it in your K8s deployment. It's maybe more about having a default at launch for the image than anything.
I was going to quibble about the JVM tuning too, because you really want to compute it based on the available memory if we're talking about some of the memory regions and stuff like that. But there are a couple things.
If you're following that point and you're saying that it's basically just providing a default, and a build pack's already providing a default, and we don't need to have pack inject an alternate default because you're going to override it anyway.
I can think of some JVM cases though, maybe not memory region tuning, but I used to do some work with Gemfire caches and stuff like that. And depending on the size of your data objects, you probably want to tune your garbage collection a little bit differently. And that is a kind of thing that doesn't vary dynamically at runtime, but it's not the kind of thing that like a build pack is ever going to know about in advance or want to know about. It may be a very specific build pack, but we wouldn't. That would be like a 5 years from now build pack when we're cleaning up all the things we haven't supported in the world.
Yeah, I think at least on the Heroku side for like some of the Ruby and Rails things, it's like potentially you might want to set like Rails M for something by default, like we set to production, but maybe you actually have built out some other environments that you want to kind of force this image onto. I think that's like a common use case, or maybe if you have like other API endpoints or stuff that it links to, you want to be able to hard code like a set of defaults that a build pack will never know about, right? It's like it's specific to my app, like by default, I expect to hit this API, right? So it's really about, I guess, like app specific configuration.
Yeah, feature flags as well. Like that's one of the things that I see, like from like a project perspective, if you're not really thinking about how you got to the final image, but making sure that final image represents what you want to run on the platform without it being different in staging or production, right? Where you might be binding things dynamically. So like feature flags being baked into the image. That's kind of my canonical example of wanting this.
Yeah, it ultimately depends on the process, right? Like handing over, if you're thinking about handing over from a development perspective to the, DevOps personnel, then you want to give an image that's already almost pretty much pre-configured, right? And not having to have additional configuration then set afterwards. And I mean, going back, like the fact that there is a build pack that provides this functionality should indicate that there is, a need for this. I mean, unless it was just done for the sheer fun of it.
Yeah, I've gotten a lot of complaints that it's poorly documented too, which indicates that people are trying to use it.
Going back to Terrence's idea about metadata for each build pack in Project TOML, that's really very interesting to me. We had for the old CF build packs, we had a buildpack.yaml file. It was just a convention where the top level thing was the name of the build pack, top level keys are name of the build pack, and build packs could read configuration that was build pack specific. We ended up killing that for build time environment variables because it was like too many ways for people to configure the same things, if that makes sense. But build time environment variables apply to all build packs, and maybe that's not really the experience people are looking for. I'm curious if that's a more general idea that's worth exploring, or like on the Heroku side, if you had similar conventions or ways of configuration that are more unified.
Same useful, but also seems restricting in some ways. Like just having, if you're looking at Rails M to make a decision today, and then suddenly they scope it to this particular build pack, and you have a bunch of build packs working in concert, then like it maybe won't have that information anymore and make different decisions. But I think it's a nice feature to think about.
Yeah, I haven't fully thought through it, but I know it's having been a pain when you're using multiple build packs of the global thing to some degree. And then it becomes hard of just like you have to define basically this weird interface of like these M bars that are specific to your build pack. And I feel like that always ends up being kind of gross.
I think it's a slightly different concern. I haven't seen it come up as much on the Paketo side, this particular concern, but one of the things I'd worry about if we did this is right now, I can sort of like, let's say I want to use a Zulu JVM instead of my Bellsoft JVM. I can kind of just like drop another build pack in the order and not think about changing my configuration. It makes them less like replaceable without having to change a bunch of other things that know about all the names of particular components.
We have put a lot of effort into that kind of decoupling where like when build packs talk to build packs, they don't know each other's IDs, right? You can make them really, really easily swappable in your configurations if you decide, like the whole dependency system is kind of based on that idea. So that's a pretty strong argument to me.
Are you passing a bunch of configuration there? to that thing where if you swapped it, you would have to change a bunch of stuff? Like,
Well, there's a couple different environment variables you can take, right? Like you can set the JVM version it's supposed to install. And like all of our different JVM build packs take the same set of flags. So if you swap one for the other, or even just put a new one first in the order, because it will consume the build plan entry and the other one won't run. Like it's very replaceable without changing anything else. But if I, in my project TOML said, pass JVM version to the Bellsoft Iberica build pack, then I couldn't as easily switch things without making a lot of changes. I think a lot of people consume our meta build packs and don't actually even know about the names of all the individual components until they need to.
Well, I guess it depends on how it's implemented, right? Like you can imagine if it's defined at the meta build pack level, it gets passed down to a bunch of stuff. But you're saying this, I guess, isn't part of your set of meta build packs for the JVM version?
It is part of the meta build pack. Like, I guess you could set it on the meta build pack, but then most of the time then it would go to everything anyways. I don't know if that solves the problem either.
Yeah, with all the like before and after build pack insertion stuff we've been talking about before, it makes me a little concerned that this would lead you to having very specific configs that don't get passed to the build packs the way you expect.
I mean, going back to the JVM tuning one there, or you could get away with passing in JVM tuning as an environment variable to your runtime if you know which JVM you're going to be running against at the end of the day and you know the exact arguments that one supports. But if you don't, then it's time to start writing a JVM tuning build pack that can, accept generic arguments of what you want it to do, and it will apply them to whichever JVM is going to be in play later further on. But that sounds quite complicated. But it does provide the decoupling. Now, I still listen to the idea of passing runtime environment variables that will be baked into an image, essentially, and worry about that slightly against the idea of externalized configuration and how, anything that you're going to bake into the image is not going to come under the list of an externalized configuration. Agreed, you can override it with your own environment variables, but the fact that you're having to bake those values in the first place is interesting, because it means that there's definitely something that you need to dig into to find out why this is still needed. Silence.
It makes sense. I mean, yeah, like you said, we have gotten this far without having to do that. So it's
yeah.
it's work we don't have to do probably, but yeah.
It is a common thing, isn't it, that people are going to want to do this because it's the easy way to avoid having to manage your configuration at deployment time. If you've baked everything into the image and the image just works when you deploy it, it's fine, but then you haven't really gained the advantage of properly externalizing it, so that you can't then run it on a different environment with different config later. You have to rebuild the image first, or know the exact environment variables. Sorry.
No, sorry, I apologize. I think it depends on the use case, right? If you're building an image that is a Minecraft server, right, to use Joe Kuttner's example, right, like that isn't intended to go into some sort of like secondary process of where the environment is tied to something else, right? It goes to a more simplistic solution, which I think we still want to enable as part of this project.
Distribution.
Okay, I can accept that.
Like the Docker run, right? You just want to run it. You don't want to have to like remember to pass in everything that your platform runs.
I guess.
Sorry, go ahead.
I say I'm quite heavily biased because most of the images I'm messing with, most of the scenarios I'm looking at are enterprise grade big kube deployments or big multi-service deployments within large scale organizations, and they definitely don't want to go the other side. But I can totally get the point that if you're just like creating a Jamula server or a whatever like home level service that you're just going to deploy on Docker because it's easy for somebody to do it that way, and Minecraft definitely fits that model, then yes, you definitely wanted to bake everything in, because the fewer arguments you have to tell them to set, then the less chance they're going to type something wrong. So
along those lines, but still thinking about larger scale enterprise kind of use cases, I think one thing we haven't talked about is folks who want to build an image and then give it to other people who aren't them and aren't going to know how to configure it at runtime effectively. So like if you're building images that you want to put on Docker Hub for an open source project for a lot of people to run, and you need a runtime environment variable, and you don't have to want to write a build pack, right? That's a situation where you're not going to be able to, it would be really annoying to document, oh yeah, everybody who consumes this image, you have to set, blah, 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 some obscure thing equals to some, constant value. It would seem really weird. And in enterprise, I've definitely seen cases where some very large organizations where the operators are not, are so disconnected from developers that the way you provide your app to them is, here's the place you put your image, and you're not allowed to define additional runtime configuration because that's, part of the IT operator, space. And as a developer, you might want that, ability, or maybe it's harder to define the, to get people to make changes at that level. So I could see arguments, kind of along those lines of when the personas are not the same.
You can also see like, I think from the life cycles perspective, at least, we should default like philosophically to sort of flexibility and allowing people to use whatever workflow works for them. And then you can sort of leave it to platforms to be a bit more opinionated. Like not every platform has to expose this feature. And maybe other platforms, like if every app that's running on it is running completely internally and they want to bake in some platform specific environment variable that does some special thing that no one needs to know about, that kind of thing. Like I think that there's a lot of workflows people can employ, and rather than guiding people towards the correct one, I think we should make correct ones easy, but also make the options that people are asking for possible in the lifecycle as well, so that people can use it flexibly.
That's very, well, the gut feeling I have about this is like, oh, not allowing people to do this feels like a lot of the decision making we made in the past around trying to create very constrained builds where the operator has an amount of control, or really trying hard to prevent the developer from shooting themselves in the foot for some reason. And I think what we saw over and over again is when we put those kind of inflexible guardrails in place, yes, it accomplishes that goal, but it's too much. it causes users to get frustrated when they can't, account for some, weird edge case. I think in the Cloud Foundry Buildpack side, historically, that was like a something I would have changed, is probably more flexibility in that respect. And so that's why I think I also lean towards saying we should add it, even if as long as platforms can turn it off if they want to, even if it's a bad idea to some extent, or if it discourages application deployment patterns that are maybe less ideal.
So we talked a lot about this being a part of like Project TOML, which is of course an extension, right? And we talked about a prepare phase that we've also talked about being sort of extension, right? Like optional. So where does this feature, if we were going to build it, where does it live in y'all's minds?
I feel like there should be we should take platform, make a build directory under it, and make that the current platform. That's what we give to Buildpacks. It contains all the things it currently does. We can also make a launch directory under it, and that's where we could build out things like files, like environment variables and profiles and stuff like that. And then in our current workflow, like if you're thinking about Pack already takes Project TOML and populates platform. So this would sort of be analogous to that. But in the future, if we had a prepare phase that read Project TOML and populated platform, we could also work similarly.
Do we have a /platform defined at runtime anywhere? Because that, something about that feels like I already don't like how much we kind of stamp on the top level namespace, right? Is this really a /layers?
We don't have to leave them in there in the exported image. Like we could copy them somewhere.
Yeah, I was going to suggest that. Yeah.
I think
that's just an input to the lifecycle. The lifecycle could do whatever it wants with it afterwards for the final image.
I think maybe /layers/platform, and then they can live on a separate blob.
I mean, it doesn't even have to say the name platform, right? Because it's not platform at that point anymore. It's just runtime environment variables or launch, which brings me to my other maybe nit here. I think from the project TOML perspective, I'd like to use the term run or runtime as opposed to launch, because I think launch is maybe very internal in context to the lifecycle and the build packs.
We use it in a lot of places, though.
I know, but within
most of
the
those places are
lifecycle.
like life cycle-y, but I feel like once
Yeah.
you have to dig into certain aspects of the spec, which people sometimes do eventually, it might be better not to have different nomenclature for the two different things.
We're very inconsistent, though. We have run images and
It's terrible. I hate us 2
Launch
years
tunnel.
ago.
Yes, probably a lot of it's probably my fault. I should take a lot of the blame there, probably.
I mean, we can still change it.
Yeah, then a lot of the terms
1.0.
when I started as well.
Yeah, I think
The
the
mythical
persona for
1.0.
someone who's using Project TOML, they don't know what launcher is. So like, run makes the most sense to me from that perspective. And whatever we have to do to make that consistent seems fine.
Yeah. Just call launcher runner.
Yep.
Okay, I'm convinced. Once I thought about the run image not being the launch image, I realized it was a lost cause.
Can we rename the build packs that are inside the builder image to something else as well? So we can have a distinction between build packs and build packs, where one is the whole project and one is the tiny things that live inside, because that's the number one thing that I'm meeting when I'm trying to explain this to my colleagues as to how this works and what we're doing. It's like, oh, you're using build packs, and it's like, sort. And then you have to try and explain the difference between writing this. I was having to explain to somebody the other day that no, the life cycle isn't something we need to rewrite from scratch to the specification that is already there. Yeah. But
You can call.
Yeah, go
Sorry,
ahead.
go ahead. No.
So the biggest confusion there basically comes down to build packs. That I'm saying build packs with a capital B, which is the whole thing, and build packs with a little b, which are the things that live inside a builder image.
You can call the things that live inside the builder image build packages as the artifact format for the thing, and that's sometimes if you're really just talking about the artifact,
I can only
but-
use that when it's that artifact. When it's on the builder image, it's not a build package anymore.
Internally, we say C and D
directory, right, which has extra ones that gets added as well. So, and that's referred to as a build pack directory, and you're like, that's not. It's sort of related, but what is a build pack at this point? Is a build pack a thing that lives in a builder image, or is a build pack a collection of builder images with build packs and an ecosystem? Like, where would you describe Paquito at that point, or Paquito? I don't know pronunciation for it, but you know what I mean. How would you describe that within the terms of build packs?
We say cloud native build packs or C and B internally a lot to refer to the project. It's different from the individual components.
I think a lot of that
CNCF
comes from having a legacy V2, because we already have to differentiate internally from the two, at least on the Salesforce side. So I imagine the Cloud Foundry is also similar.
Yeah,
Well, which
for
one
sure.
do you use that to refer to? Because I'll use that to refer to both the project and the individual things if I'm trying to differentiate from the previous generation. I don't use it to differentiate between project and build packs. I say build packs project versus build packs, I guess.
Yep. Yeah, I use project afterwards if I mean the whole thing.
Okay. So it's not just me that gets confused and needs to clarify the context whenever trying to explain something in a sentence that involves both then.
We're just clear that it works at this point.
Yeah, no, it works well. It does its job.
All right. So as far as going back to the RFC, I'll try to draft something up or delegate. We'll see which one comes out first.
Did we land on where the end files end up in the image? Like
I was
under
hoping to be
layers
able
or-
to work through when drafting the RFC, asking questions on the implementations Slack channel to figure out those details, because it does seem like it's more opinionated on that side of things. But the high level feature, that's what I want to care about. Does that
Layers
work?
directory, probably.
Sounds like a good swing. Good first swing, sorry. All right, who's facilitating?
Did you just
Uh-oh.
volunteer to take over, Javier?
Apparently, I don't know.
Alright,
It's just
there's
I heard
nothing else.
silence. We're done.
There's nothing
Yeah.
else on the agenda.
I think we don't have anything else on the agenda today, right?
Nope.
Yep.
So we can call this. If people have ideas about runtime environment variables, maybe open an RFC, kick it off on GitHub.
Maybe I'll start it off as a discussion and just throw our ideas in there first and then formulate it afterwards.
Sounds great. Thanks, everybody. Give Bright 15 minutes back. This was great for a small group on a Thursday. A lot of good
It's
discussion.
very good.
Thanks.
Take care all. See you. I feel sure we met at some point as well, but end.